Hi, we're Yagüeyi and Anthony Lor, and we are going to present the design of a network for geopositioning based on LoRaWAN. The problem: geopositioning systems are increasingly required in many industries. Real-time locations applications are very useful to facilitate monitoring tasks. For more demanding commercial applications, GPS does not offer a cost-effective solution, since GPS consumes a lot of power and it is expensive to implement. Society considers the use of geopositioning systems to be increasingly important. This can be seen in the large number of uses that have been given to geolocation technology. Even GPS in the beginning can only be used effectively for the US government military. For GPS-based systems, the number of satellites in orbit has increased, which has led to the use of many resources that affect the environment. In addition, the high power consumption of GPS receivers means that their batteries are disposed more quickly. The impact of geopositioning on Industry 4.0. It is used both by the technology sector and the production sector. It focuses on the quality control, product monitoring, workplace safety, resource utilization, and supply chain management. The Internet of Things requirements. IoT applications require low data rate, low power consumption, and many devices connected at the same time. Wireless technologies such as Zigbee and Bluetooth can be used as they have some of these features, such as low data rates, but they are not designed for long-range communication scenarios. Cellular-based solutions also provide long range, but consume too much power to be viable. For this purpose, a new group of technologies has been created under the name of LP1. This set of technologies is designed to meet the requirements of the Internet of Things. It provides long-range communication, low energy consumption, a large number of devices connected at the same time. There are several LP1 technologies, such as of which LoRaWAN has been chosen. LoRaWAN was chosen because it is on the top 3 of the most popular LP1 technologies. Due to its popularity, many researchers review the potential of this technology, which generates a large number of useful applications for society. In addition, LoRaWAN is free to use. Other LP1 technologies are proprietary, which means that you have to pay the company that created them to use them. Given its extensive technological development, the rise of this technology gives way to new functionalities, such as localization using LoRaWAN. Since a LoRa gateway can cover areas in the order of kilometers, LoRaWAN is a great candidate for geolocation applications. LoRaWAN gateways can be used to locate a moving target, for which there are several techniques. The trilateration technique is used for this project since its implementation is simple and it requires few computational resources. To use trilateration, you need at least 3 gateways. To use this method, you need to know the distance from the target to each of the gateways. To estimate this distance, you can use the time it takes for the signal to reach the target, or you can use the signal strength received at the gateway. In this project, the second option is used, since it is easier to estimate the distance this way. If time is used to estimate the distance, it requires that the gateways and the node are synchronized, which leads to a greater complexity in the implementation of the network. Next, my partner.
Hi, we have developed a simulation and we're going to use the Flora framework that is available in ONNET++. For that, we have the following architecture. Here we have modified all the important parameters to comply with the trilateration algorithm. We have one area of 1 kilometer per 1 kilometer. We have one mobile node and we have 3 gateways. Now we have defined the coordinates of each node and each gateway to comply with the trilateration algorithm. And also we have added the mobility type. In this case, it's going to be circle mobility and it's going to have a radius of 25 meters. Also, we have for the node some very important parameters as split factor, the power transmitted, the bandwidth, and the conduit rate. Now we're gonna show the topology in work. As we can see here, we have the 3 gateways and the mobile node. As we execute the program, we can see the node is moving, and then it's gonna send the first trace. Now, how can we extract results from this simulation? We have the following parameters. Here in the console, as we can see, we have the gateway 0, the gateway 1, and the gateway 2. For the gateway 0, we have an RSI value of -116. For the gateway 1, we have -123, and for the gateway 2, we have -126. These 3 values are the RSSI values for each gateway. Also, we have the power consumption for each gateway 2 in the console. How can we use the RSSI value to relate that value with the distance? For that purpose, we have developed a simpler topology. Now here we know the distance between the gateway and the node. So now we only have to see what value of RSSI we have. So now we can relate this distance to this value. After that, we have the following table. We have repeated the experiments a lot of times, and now we can link this RSSI value with this distance. So now we can process and apply the trilateration algorithm. For that purpose, we have in the center of each circle the initial position of the gateway. And now the radius of each circle is the distance which we have obtained from the RSSI value. Now we have a system of 3 equations and 2 unknowns. After solving that system, we have the X and Y coordinates of the mobile node. But how can we improve the coordinate acquisition? For that, we have developed a Python code, which receives 9 parameters. The 6 first parameters are the X and Y coordinates of each gateway, and the other 3 parameters are the distance from the node to each gateway. With that value is obtained by the RSSI table. As result, we have that this network can use 7 times less energy than GPS, and the average location error is 18.81 meters. This is very low if we are thinking about the wide range of coverage of LoRa, because it's in the order of kilometers. Also, this error is very similar to the GPS error. For application of the proposal and future lines, we have the functionality of the network have improved, and the aim is to promote the use of LoRaWAN device applied to geopositioning. Also, we can think of final apps for the final users, and with this app, we can process the coordinates in a better way, so the final user can see, for example, an application similar to Google Maps, and the position of the mobile node is updated in real time, and the user can locate it on a real base map. Thank you.